section 3.3. In this section, we're going to learn about the basics of the atom. Now, according to Dalton's atomic theory, and you may go, well, who was Dalton? Well, John Dalton was this incredible man with incredible foresight. He was about in the late 1700s, early 1800s, that he came up with his atomic theory. And he became a school teacher at age 12. Catch that, age 12. And so then you might think, well, what's the big deal about his atomic theory that he came up with in the late 1700s, that atoms are tiny particles of matter? Of course we know that, but that was the late 1700s. And so he came up with that atoms are tiny particles of matter, and then if you actually look at the word for what atom means, then you see that elements are similar to each other, but different from other elements, that two or more different elements combine to form compounds. So in other words, we have the different elements are going to combine to form compounds in chemical reactions, and that they are rearranged to form new combinations in these chemical reactions. And you go, well, so what was the big deal, and why was this so amazing? And why has this kind of held on for, the last several hundred years? Well, because before his time, we only really had the philosophers that kind of said, well, atoms are all alike of everything, and you had earth, wind, and fire, and that was it. Well, thank goodness John Dalton came along, and even though that was many years ago, as science continues to tweak this, we learn more and more, and the field of astrophysics right now is just amazing. And the movie that came out not too long ago, Interstellar, talking about lots of different things and just kind of blows your mind away. So in chemistry, we quite often like to say, yes, we have these theories, but we keep doing experiments in hoping to learn more and to dispute different parts of the theories. Other people want to go, oh, well, this is the theory and everything better be right on it. Well, in chemistry, we want to keep learning more and more. And with the astrophysics, they're really, with the CERN, where they're slamming these atoms together, this is really helping to learn a lot more. So let's learn the basics that have been around for a while, that are probably exactly what I learned a million years ago, and what you're going to be exposed to, but hopefully your grandchildren, or maybe even your children, or who knows, maybe even you, as we continue with science, are going to learn even more. But our basic items is that atoms contain subatomic particles. Yes, we know that. So the three subatomic particles that in chemistry that we'll be talking about are protons and electrons and neutrons. So those, don't think that those are the only things, but those are the only things that are big enough for us to worry about, that we're going to deal with in chemistry. So what we need to learn about is that protons have a positive charge, electrons have a negative charge, and those two charges balance out. Now, neutrons are neutral, hence the name neutrons. All right, and so an atom itself is overall neutral charge. Another thing we need to make sure that we remember from when we were kids and we played with magnets, that if you had two like charges, they repel. If you have two, whether they're positives, they're going to repel, or whether they're negatives, they're going to repel. And if you have unlike charges, like a positive and negative, this is what has some attraction and causes things to be attracted to each other. All right, so the next famous scientist that helped us understand about the atom was Rutherford. And he did this very famous gold foil experiment. Now he thought that so let me go to the next slide. So he thought that if he shot this beam through this gold foil, because gold is so dense, that he expected the items to be totally deflected, which is what he expected. Because think about it, let's say that you're out target shooting and you're shooting at a can that's on top of a rock, and you totally just miss the can and you hit the rock. What's going to happen to that bullet? It ricochets, and that's probably why they just assume you weren't out there doing that, because it might ricochet and come back and hit somebody or something. But that's what they fully expected this to happen. Why? Because gold atoms are dense, so if you hit a bunch of dense things, it's going to ricochet back. Well, what totally blew the scientists away was the fact that the particles went straight through for the most part, and only a few of the particles deflected back. So let me go back. And that when they deflected back, the term was, it was almost like it was shot out of a cannon coming back. So from this, they were able to totally have to rewrite what they thought at the time of what an atom looked like, that it wasn't this solid piece, but that the atom was actually empty space with a small, dense, positively charged nucleus in the atom. Why? Because it was deflecting the positive charges that got close. You go, well, that doesn't make sense. How can you have something make up something that's mostly empty space? Well, I need to point out one more item. That small, dense, positively charged nucleus, they compare it to like a penny in a baseball field. That the nucleus is like the penny, and the whole rest of the atom of empty space is like a baseball field. And you go, that still doesn't make sense. Well, let's see what's making up the baseball field part. Well, that has to do with the electrons. And you go, electrons? What are the electrons doing? Well, they're zooming around, and they are occupying the space. Notice there's a little bit of difference there when we're talking about that they occupy the space as they're zooming around. So think of this very hyperactive kid as he's bouncing off the walls in his bedroom. He occupies that whole space, and you probably, aren't going to be having a lot of other things in there because, a lot of other people, because that kid is taking up the entire room with him bouncing off the walls. So here's the point. We have an atom that in the center you have a nucleus that contains protons, and you have electrons zooming around out there. Now you'll notice, as I'm here on this slide, I now need to mention neutrons. That comes along later, but it wasn't until when they were smashing atoms into each other that they were able to discover the neutron. Why? Because it was neutral. Kind of hard to find things at that time with the tools they had with something that was neutral. And so the nucleus makes up the mass. The mass has the protons and the neutrons, and the electrons are zooming around outside of the nucleus, and they make up most of the space. All right, so everything actually is compared to, when we're talking about a mass, it is compared to carbon. So the carbon-12, so for example, a hydrogen with one proton, it's about 1/12 of the mass of the carbon-12. So that's why we come up with this number. And so a proton has a mass of about 1 AMU. When you go, what's an AMU? That sounds like an MU. No, it's an AMU, atomic mass unit, and that's what they're comparing it to, the mass of the carbon-12. Now, a neutron has a mass of about the same amount. We'll just call it 1. Protons and neutrons both have mass. Now, if you were in physics class, you would say, okay, the neutron has a little bit bigger mass. Well, in chemistry, at this level, we'll just say they have a mass of about the same. We'll also say that an electron's mass is so small, look at this number, 0.000549 atomic mass units, that in chemistry we're going to say it has no mass. You go across the hallway and be taking a physics class, they're going to be using the mass and the very small numbers to be doing different calculations. So let's see, which of the following subatomic particles fits each of the descriptions below? A, found outside of the nucleus. Okay, well, that, I'm hoping you know, is an electron. B, which has a positive charge? Well, the only thing that has a positive charge is the proton. What has a mass but no charge? Well, that's the thing that's neutral, i.e. neutron.